Okay, we're going to get started on question number 2 off of your test for corrections. And as I'm grading these, I want to talk about a couple of things. One, if the polynomial is factored, I don't know of a case in which we've actually multiplied it out before we've started doing the graphing. We always want to take that polynomial and we want to factor it to get our x-intercepts, our solutions, our roots, our zeros, whatever. But we never took the polynomial and multiplied it out. That's kind of like going around in circles, guys. So I've already given it to you in a factored form, and that's what form you want it in. Okay, you want it in factored form, guys. So some of you are doing some really weird work. I'm not sure why you're doing it. Again, it's not something we ever did in class. So again, we're going to talk about the degree of your polynomial. And remember, it is your highest power or exponent. And as I showed you in the last one, if you watch that, when we take this is a exponent with a 1. This one over here has a 2. So we have a 1 and a 2. And if you think about multiplying it out, okay, you're going to have a x squared on this one over here. Okay, this one's going to give you an x squared. And this one is going to give you just an x to the first, which is an x. And if I put those together as rules of exponents, I have an x3. And so the power here would be a 3, a third power. Okay? But don't multiply it out. You can just look at that and tell what degree it is. B. So that was A. B asks for what information about the behavior. Okay? This is talking about the behavior of the graph. Guys, when we talk about behavior, we talked about end behaviors. In other words, what does the ends do? So when we're talking about the behaviors at the factors, okay, at those factors that are up there. So we've talked about this over and over about what happens. So if it is to an even power, okay, I even, for some of you, I made a thing on the board, gave you some notes on this. Some of you, we didn't write it out as clear, but it was in your notes on the videos. So even power, again, always touches and bounces. Okay, odd power, okay, goes through. Now what I mean by there is goes through that x-intercept, that point, okay? So don't just give me that though. I need to know so that you are clear on what the graph looks like. So when I go to look at this one up here, I know it is going to touch and bounce at -1, 0. Okay, because that's my even power. I know it's going to go through at, in this case, 2, 0. So be very specific on your answers. You can't just say it touches and bounces. Well, what touches and bounces? Okay? C. This one says the end behaviors. And I even started it off for you. And so when you're looking at this is a cubic. Remember, cubics either look like this or they look like this, according to whether our A is positive, okay, or our A is negative. Okay? Either way. So in this case, our value here is just a 1. So it is a positive value. I should say 0 here, not 1. So it is a positive value. So that means it's going to be this graph. And so as I go to a negative infinity, this graph is going down, which is a negative infinity. If I'm going to a positive infinity, I'm going to a positive infinity. Okay, that's all you had to do. Remember, we talked about it. If these are odd, these are opposite of each other. If they're even, those should be the same answer. D, y-intercept. Guys, we've been doing y-intercept since chapter 2. Y-intercept is the point where the graph crosses the y-axis, and it is always where x equals 0. So it is a point, 0 something. If you can't just look up there and figure it out, then put the 0 in. So 0 minus 2, 0 plus 1 squared. So I get a negative 2, and 1 squared, which is a negative 2 times 1, which is a negative 2. And do I expect you to do all that work? No, I would hope you can do this in your head, but some of you need to show all the work. So that is my answer to D. Okay? E. Again, E asks for the real zeros. Guys, real numbers. Okay? Real numbers. Let's talk about what those are. You got two different types. You got real and you got imaginary. I ran out of space over there. Your real numbers, guys, are basically any number you can think of. You know, pi, 1/3, 3/4, okay, negative 100. Those are all real numbers. Imaginary numbers is the square root of a negative 2. Okay, square root of a negative 4. Because I'm going to get that I, remember, 2i. Those are imaginary numbers. Real numbers are any others. So when it says real zeros, what it means is, just like when we put in, we'll do it here in just a minute, but when we set this equal to 0, that's what we're talking about, real zeros. In other words, what are our x-intercepts? What are our solutions to that equation? What are what we call the roots? Guys, I can't tell you enough, those all mean the same thing. Okay? So we want to know is find the real zeros for this one and state the multiplicities. So I'm going to pull my equation back down here. So it was x minus 2, x plus 1 squared. Okay? So this is where we set each of our factors equal to 0. That's why it's called real zeros. This is equal to 0. I don't need to write that one down twice. Earlier you should have stated it has a multiplicity of 2, or in some form of it up above where we're talking about the touch and bounce. And guys, if I go too fast, then stop it. Back up and replay it. That's the whole point of doing a video, is to allow you to control what you see, how fast you see it. Okay, so if I say it too fast, back it up and repeat it. Again, this had a 2 here, so this is our multiplicity of 2. How should you tell me the answer? Okay, well, the best way would be to say x equals 2 and a negative 1 with the multiplicity of 2. Be sure that that multiplicity is beside that negative 1 so that I can tell on there which one it goes to. Don't put it in front or underneath, way over here. You know, put it underneath the negative 1 so I could say I know which one it goes to. Okay? When I tell you to state the multiplicity, I don't mean for you to tell me negative 1, negative 1. Okay? That's not what I'm meaning by state the multiplicity. I'm meaning you tell me which one is a multiple. And again, that is supposed to help reinforce this touch and bounce. Okay? So, let's look at what we've got. Okay? So, we have that this is a degree 3. We have that our graph will look like this. We have that it's going to hit at 0, negative 2, And we also know that it's going to hit at 2, -1, 2 and -1, that the -1 has a multiplicity of 2, which means that it's going to touch and bounce at a -1, and it's going to go through at 2. So I'm ready to sketch my graph. Now, let's talk about the graph just for a little bit. Let me give me a different color here. I'll go purple this time. So I'm going to put in 0, -2. There's my y-intercept. I'm going to put in the 2, and I'm going to put in the -1. Now, we said that this was a multiplicity of 2. It's going to bounce off of that. We also said, guys, remember up here, that this is what my graph looks like. Whoops, right there. Okay? So that means that I'm going to be coming down here. Now, let's talk about the graph. Some of you are getting way over here to start your graph. It's not going to be coming in that steep. It's just going to come up from the bottom. Whoops, it's hard to control here. And it's going to touch and bounce. It's going to more than likely go through this because we're so close here, and then back up. I see some of you guys that are coming in with your graphs and you're trying to just cut everything really short, okay, and you're just jumping it. Okay, it's not, generally these are not going to jump that fast, okay? They are going to be gradual increases and decreases. And if you've looked at those on your calculator or Desmos or something, you should know that they're more flowing, okay? Nothing should look like a straight line. It's curving all the way, okay? And so put that, it's curving all the time, okay? No, never straight. Okay, next bit is to state the local min and the local max. And I told you for what we're doing, this is G, this is F. So what I told you for what we're doing, since I did not give you the graphing calculator, that you could just do intervals unless you specifically knew the answer. Well, when I look at this graph and I'm looking at my minimum, remember this piece and this piece do not count in your max or min because those are infinities. So local max and local min means the other place where you see there's a minimum. So you can see right here, this is a minimum value. You can see right here's a maximum value. So when I go to do the minimum, well, I don't really know where that's at, right? Because I could have drawn my graph like that, or I could have drawn it like this. I don't really know, but I do know it's going to fall somewhere. Technically, it's going to fall somewhere in between here because I know that -2, okay? Now, I accepted as an answer if you told me a -1 to 2. I accepted that. But really, it should have been from 0 to 2. Okay, now this is the interval because I don't know an exact answer. Okay, so we do an interval when we don't know exact. Okay, now here's the opposite one though, because when I come over here to this other point right here, I know it's touching that and bouncing off of it. So it's never going to go any higher than that point, okay? But I'm asking you how high it goes, okay? I'm asking you how high it goes. Well, height, guys, is your y value, and it's never going to go any higher than that. Well, that point is 0, so y will never be higher than 0. So we say the max is at y equals 0, okay? I could not say that here, okay? I couldn't say it here because I didn't know exactly what it was. All I could say is, oh, it's between these 2 points, okay? Had I given you the graphing calculator, that would have been different because you could have given me a specific point. But unless you start trying a whole bunch of points, you're not going to be able to give me that minimum or maximum on this interval here where it's in green. Okay, again, those are all the things that we've talked about.